Well, hey, everybody, it's your boy, Mr. Perry, and here we are. We're going to be starting. This is really technically the second half, or the last little bit of lesson 5, and then all of lesson 6. And really, what we're getting into are now that we're learning about Boolean expressions and how to evaluate them, and how to use truth tables to see if they are equivalent. Um, we're also going to look at some shortcuts. We're going to look at some ways that we can actually save ourselves some work. And then we're also going to look at some other tools that we have to evaluate some of the more complex expressions that we're going to see. So I call this one shortcuts for truth tables. So we're going to be looking at what's called short-circuited evaluation. We're going to learn how to do what's called distributing the knots. And then we're going to be looking at De Morgan's laws. So a lot of important stuff to get into here. Let's go ahead and get started. So shortcut number 1, this was mentioned at the tail end of lesson 5 in CSAwesome. It's called short-circuited evaluation. So basically what it means is if you're looking at an AND type situation, when you have a condition A and a condition B, if condition A is false, then the entire thing is false, and you don't even really have to look at condition B. So it just basically saves you a little bit of work, right? And so here's a really simple example of it. You've got int x equals 10, and then it says if x is greater than 20. Right there, you can just basically stop and say, all right, well, this is false. This is an and. So I don't even really have to care about what's going on over here. I can basically just go ahead and say, this isn't going to work. This is automatically false. So here, who cares about the whole thing? The whole thing is going to be false. And there you go. And similarly, if you're looking at a condition 1 or condition B situation, if the first condition is true, then again, the entire thing is going to be true. So like I say, similarly, if you say int x equals 10, and then you've got as long as x is less than 20, or, well, again, boom, you automatically know this is going to be true. So that means the entire thing is going to be true. And you can save yourself some work by by not even looking at this part. As long as this is all there is. Now, if there's a bunch more going on and there's like other ands and things like that, you might have to evaluate it. But in this kind of a situation, it's simple enough where you can just say, okay, this is an or situation. This is true. I know the whole thing is true. I can move on. So it's helpful with problems like what you see right here. All right. We've got an if statement, but what you'll notice is that it wraps. So you've got this entire thing right here, and then you've got an or, and then you've got all of this over here. It looks like a ton of work. And so again, we've just got to see, all right, how do we approach doing this one? At face value, this looks like it's going to be a really challenging question. But because we've got an and on the inside here for this first set of parentheses, and then we have an or situation, and then all of this, maybe we just need to do this first part over here and then see if this is true. So A is set to 4, and A mod 2 is actually equal to 0. So we know that this is going to be true. And then B is set to 8, and B mod 2 is also going to be 0. So what that means is you can easily tell that this condition right here is going to evaluate to true. And since the entire thing is an or, then you can just completely ignore all of this over here. You don't have to do any of this. All you really need to recognize is that, okay, this is going to be true. So that means we're going to print past test 1. And there you go. So it just kind of saves you a little bit of help, or it saves you a little bit of work. Now we're going to look at shortcut number 2, which is distributing the knots. So oftentimes you can simplify an expression by distributing the knots. So what that means is if you have a not sign and it is outside of the parentheses of a condition like this. So we've got an A is equal to B. You can actually take this not sign and distribute it to the middle because not A is equal to B is equivalent to A is not equal to B. So it's just like you're taking that exclamation point and moving it to the middle. And this is the same. So sometimes it's easier to evaluate A is not equal to B than it is to evaluate not A is equal to B. Similarly, if you have if your Boolean expression is A is not equal to B, but if the entire thing is wrapped with parentheses and you have a not out here, you can distribute that not. You can move that not into the middle and just make it A is equal to B, because not A is not equal to B is equivalent to A is equal to B. And then it's also useful to know that if you have not A is greater than B, that is equivalent to just saying A is less than or equal to B. Because if something is not greater than something, then it must be less than or equal to it. And then same thing down here, if you say not A is less than or greater than or equal to B, that's the same thing as saying A is less than B. Because again, if A is not greater than or equal to B, that means A must be less than B. And then same thing down here, not A is less than B is equivalent to A is greater than or equal to B. And then finally, not A is less than or equal to B is equivalent to A is greater than or equal to B. So this is good to put on your radar. This is good to memorize, just to remember that if you have a not sign outside of parentheses, you can often just distribute that not to the middle of it, and you just need to switch the operators. So there is that. Notice again, all you have to do is switch the sign between A and B in order to make these equivalent expressions. So not A is not equal to B is equivalent to A is equal to B. All we did is flip that to become that. Not A is greater than or equal to B, we just take this and we flip it. And again, A is less than B. Finally, not A is less than B, we just take this part right here, we flip it, and we put it over here. It's equivalent to A is greater than or equal to B. So that's how you distribute the nots. And oftentimes we can actually simplify an expression by distributing the nots. So again, we're looking at this one here, and I see if not A is not equal to B. This is kind of confusing, right? And then we do have another not over here. This is not, and then there's an extra set of parentheses. So it's not this is greater than this. So let's see what we can do here. This kind of hurts my brain. So you can simplify the expression by distributing the nots and then seeing what that simplified form is. So we would rewrite the Boolean expression by distributing the nots. So we take this not and move it to the middle, then that means A is equal to B. And then again, I can take this not and I can move it to the middle of this one here, and I can go ahead and flip that sign. And now this is a lot easier for me to work with. It's a lot easier to comprehend an expression like this where all of the exclamation points are gone. So it's important to know that you can distribute those exclamation points. You can distribute the nots, and that's going to make things a little bit easier, usually. And so now you can look at this and say, okay, well, let's see. This is my condition A, and then I've got an or, and then this is, I can kind of look at this whole thing as my condition B, and say, all right, well, let's see. 10 is not equal to 25, so that's going to be false. But let's see. B mod 5, which is going to be 0, is less than or equal to A mod 5, which is also going to be 0. So I know that this whole thing over here is going to evaluate to true, which means I would pass test 1. Now we're going to get to one of the more important ones, which is De Morgan's Law. And with De Morgan's Law, there was a mathematician named De Morgan who proved a couple of things. He proved that not A and B is equivalent to not A or not B. So this is important to know, right? If we have a situation like you see down here, all right, this looks really, really complex. We've got num1 equals 10, num2 equals 25, and it says if not, and then in another set of parentheses, we've got num1 is greater than or equal to num2, and num2 is less than 0. But the question is, how is this not going to impact how all of this works? So what we can do is we can say, instead of looking at this as not condition A and condition B, which is how this is set up right now, we can change it to be not A or not B. So if I take my not sign right here and I say, well, this is condition A, what is not A? Well, not A would be flipping our math signs in the middle here. So making this num1 is less than num2 is going to help right there, right? So condition A is num1 is greater than or equal to num2. Condition B is num2 is less than 0. But we want to get rid of that not. We want to distribute that not, and we want to apply De Morgan's law. So now we got to look at, okay, well, what is not A? Well, not A would be num1 is less than num2. And then again, not B would be num2 is greater than or equal to 0. And then the other thing that we would have to do is we would have to change our and sign into an or sign. All right, so again, this is what we started with, not. Here's condition A, and then and. Here's condition B. And again, the not is in front of it, so we need to flip this math sign. We need to flip this to be an or, and then we need to flip that math sign. So that's how we end up with this version of it over here. We've just applied De Morgan's law, which again allows you to kind of simplify things a little bit. This is a little bit easier to evaluate. Now you can just clearly see that num1 is less than num2, so this is going to pass, and it's going to pass test 1. Now, De Morgan also proved that not A or B is equivalent to not A and not B. So we have a similar type situation happening down here. We've got our two int variables that have been declared and assigned a value. And so now we're going to kind of break this down. So condition A is this condition right here that's in blue. Num1 is greater than or equal to num2. Condition B is this one over here. Num2 is less than 0. I recognize that we have an or sign right here, but I also recognize that I've got a not sign over here. So my goal is I can look at this as a not A or B situation, but according to De Morgan's law, it's equivalent to not A and not B. So now I take my not sign and I put it in here. I'm going to flip my math sign, so that's going to be less than. I've got to change this to be and then I've got to change this to be greater than or equal to. So that's what we end up doing on this one. We can simplify things, and we can now look at this as num1 is less than num2 and num2 is greater than or equal to 0. So once again, you would go ahead and look at what we've got going on here. Num1 is definitely less than num2. That's true. Num2 is definitely greater than or equal to 0, so that's going to be true. That means we're going to get true and true. So the whole thing is going to be true. We are going to pass test 1 once again. Okay. So here's a sample question from the College Board. These are the kind of questions that we might see on our AP exam. I would encourage you to pause the video and try to work your way through this one and see, all right, considering everything that we just learned and all of this stuff about De Morgan's law, you know, which of these down here would be equivalent to what you see up here. So feel free to pause the video and try it out. I'm assuming you've paused the video. We're going to go ahead and check this one out. So again, how would we go about doing this? Well, first off, I can recognize that out here I've got a not sign, and it's wrapping this entire thing. We've got, you know, the parentheses are here and here. So I can look at this as here's my condition A, and then it's or, and then here's my condition B. Now, let's see. The first thing that we would do is we would need to get rid of this not sign. So I'm going to go ahead and, well, actually, let's not do that. Let's just go ahead and see if we apply De Morgan's law. We can take this not sign and we can say, well, what is not A? Well, since not A already has a not sign in front of it, so not A and B, the opposite of not A and B is just going to be A and B. So I can, you can kind of look at it as this not sign and this not sign kind of cancel one another. So there is that. But then, let's see, we've got our A and B. We know that's going to be part of the solution here. So we can automatically go down here and say, well, it's probably either A or C, because, again, we've got A and B, which we know is not A. And then we also have to flip our or sign to become an and sign, according to De Morgan's law. And then, so we just have to figure out, okay, well, which one is going to be not B? Well, not B would be, let's see, we'd be looking at not C and D for this one. And so, all right, well, here we go. This explains it. I forgot I've got a whole slide over here that explains it. So again, if we're going to break this one down, so, all right, so not A or B means that we can apply De Morgan's law. So condition A is not A and B. Condition B is C or not D. So again, we've got to figure out, well, what is not A? If we're going to simplify this, what is not A? So again, this one's easy because we just take out the not sign and it's A and B. But then again, applying what is not this condition. So again, we just apply De Morgan's law to it. So it's going to end up being not C and D. So not B, again, when we apply De Morgan's law to this one right here, ends up being not C and D. So we put them all together and we form not A and not B, which again was option A that you see right here. So there we go. Here is option A. Yay, we did it correctly. All right, well, let's go ahead and wrap this one up. So De Morgan's laws can be applied to Boolean expressions to create equivalent ones. And again, what we want to remember is that not A or B is equivalent to not A and not B. We also want to remember that not A and B is equivalent to not A or not B. A negated expression with a relational operator can be simplified by flipping the relational operator to its opposite sign, which is what we did when we said, instead of greater than, we distribute the not and it's, less than or equal to. So just remembering to flip it to the opposite relational operator. Truth tables can be used to prove that two Boolean expressions are identical. And again, equivalent Boolean expressions will evaluate to the same value in all cases. So we've now had our crash course in truth tables and some shortcuts and equivalent Boolean expressions. Go ahead and leave a question or a comment in the video here, and I will see you guys in class.